All right, folks. So in class on Monday, we introduced the concept of calorimetry, and in my D block class, I didn't quite get through all this, so you're just going to have to be smarter about this. But if you recall, especially if you're D block, we came up with an equation that related all the pieces that we need to relate when we're doing calorimetry problems that began with this term Q, which is the amount of energy that's in the system, either released or taken up by the reaction. So we have this Q equals mc delta T. And you may recall that m is the mass of the water. And of course, it seems strange to think about mass of water instead of volume, but don't forget that 1 gram of water is equivalent to 1 milliliter of water, so it essentially is one and the same. C refers to the specific heat of the solution, and don't forget that in this case, our solution was water, and C for water is 4.184. What is kilojoules? No, it's just joules per gram degree C. So that's an important number for us to probably stick in the back of our mind and remember. And in fact, you should know that that is equivalent to what we refer to as 1 calorie. Okay, so that's where we get the term calorie from. All right. I guess I should go back and remind you that specific heat is the amount of energy it takes to raise 1 gram of a substance 1 degree C. So in this case, the substance is water. So if I had a 1 cubic centimeter volume of water, the amount of energy I'd have to put into it to raise it 1 degree C would be 4.184 joules. Okay, so and then delta T clearly is the change in temperature. Delta always is going to be change in temperature. Let's imagine then, for a moment, that we have this information. Okay, so what we have here is we put a block of copper into this hot block of copper into this water. And after waiting for a couple of minutes, the water heated up to 27 degrees C from 20 degrees C. And I also know that I have 100 grams of water in this very small beaker. And, and then we gave you the C here. So that means we have all the information to figure out the amount of energy that this system released. So we take our mass of the water, we take the 100 grams, we take our 4.184 joules per gram degree C, we take our temperature change, which is 7 degrees C. It went up, right? And when we put all these things together, obviously if you take a look at this here, I'm going to get my pointer, the degrees C will cancel out, the grams will cancel out, leaving us with the joules that we're going to have for this system. So when I put that into my calculator, I get 2,928.8 joules. And if I wanted to convert that to kilojoules, because that's typically what we use in chemistry, that becomes 2.93 kilojoules. I'm not quite sure why I decided to truncate that to just 3 sig figs. We should have only had 2 sig figs. Oh, actually, I guess we only should have 1. Let's pretend. Those are all decimal places right there. So I should have 3 sig figs, naughty Chang, 2 sig figs, which means I get rid of that one right there. Oh, let's just start that again. So 29 kilojoules. And of course, we know that this is 29 kilojoules that was given off by this block of metal. So if it was given off, then we need to associate a negative with that number of kilojoules, since it was an exothermic reaction associated with that block losing energy. Okay, so Q's are pretty easy, and keep in mind that Q's can apply to anything, and it's just the amount of energy given off by a block of metal, the amount of energy given off by a human being. It could also be a chemical reaction, so it's a generic term for energy. That's going to be a little different when we start talking about enthalpy change, because when we're doing enthalpy change, we're going to be very specific to chemical reactions and in fact moles associated with the chemical reactions. So let's see what that's all about. Okay, so let's take a look at this problem. It's a little bit different than what you just saw with the calorimetry problem, but in many ways it is the same too. So I ask here, how much heat will be transferred, which means either it's going to be released or it's going to be taken in, when 4.72 grams of carbon reacts with excess oxygen according to the following equation. Now the part of it that you're probably confused by is, what the heck is this all about? What does this mean? And what this means is, this is the standard enthalpy change associated with this reaction. And so if you have 1 mole of carbon, it's going to, and it doesn't really make a difference how much oxygen you have, but if you start off with 1 mole of carbon, it will lead to the release of 393.5 kilojoules of energy. Okay, so we know that that's the case. The little degree sign here indicates that this is happening at 25 degrees C and 1 atmosphere, which are standard conditions associated with these kinds of word problems. So it's not going to be too difficult for you to figure this out. It's simply a matter of doing a stoichiometry problem here, because we know now, we have an equivalency that 1 mole of carbon is going to release this many kilojoules of energy. But of course, we don't have 1 mole. We have 4.72 grams of carbon. So what do you need to do? Yep, you guessed it, a mole conversion. Okay, so there we have our given that we have here, the 4.72 grams. We have our equivalency for the mole conversion, and this is going to lead to the production of but this is equivalent to 0.393 moles of carbon. We also should note here that this is going to be an exothermic reaction, so it's going to be energy that's released in this process. And so, anyway, let's take a look and see what we would do next. We need to consult with the our reaction, which shows that there's 1 mole of carbon in this reaction to produce 393.5 kilojoules. So here's my next equivalency. Okay, you shouldn't be too surprised to see that the setup that I have right there with the equivalency. And if you were to chuck this into your calculator, it would be negative 155 kilojoules of heat that would be released. It is important that you add that heat is released, so I know that you know that it's an exothermic reaction. All right, so there you go. We've now done a very basic problem for when we do enthalpy change word problems, and we've also done a fairly basic problem when it comes to calorimetry. Those are going to be super useful things for you to learn moving forward. Bye.